Now it's important that we can easily convert between degrees and radians anytime we need to. So we've already seen that 360 degrees, or 1 full revolution, is 2 pi radians. Now let's use that, halving both sides. This means that 180 degrees must be equal to half of this, which is just pi radians. Now we've also seen that it's sort of optional to write that word radians at the end. We could just say 360 degrees equals 2 pi, and 180 degrees equals pi. We'll leave the radians there for the moment though, as it helps you probably to actually write that word down. Now, the 2 conversions we need to know what 1 degree would be equal to, and we need to know what 1 radian would be equal to. That way, no matter how many degrees or radians we have, we should be able to use that as a conversion factor. So let's say to ourselves, this is to this as that is to that. How do you get from 180 degrees down to 1 degree? And keeping things in proportion, you can only multiply or divide. Grab another colour here. Well, this is 180 times smaller, isn't it? So clearly we've divided by 180 over here. So if we divide by 180 on this side as well, what we'll get is pi divided by 180. And we can write radians on that if we want to, just to keep it nice and simple. Now we can say this is to this as that is to that to try and find out what the conversion is for 1 radian. Now how do you get from pi radians down to 1 radian? Well, you need to divide by pi, because pi divided by pi is 1. So to get from here to here, if you've divided by pi, then you need to do the exact same over here, and we'd get 180 degrees divided by pi, which is easily written like this. And that gives us our 2 conversions now, which we've got our working there to show how we did them. You can either write that in your notes or not to make it make sense to you. But one way or the other, we need a nice fancy box around this because these are our conversion factors. Now, thinking about how we're going to use them. Both of them look the same in that they've both got a pi and a 180, and they're just flicked up the other way from each other. They're the reciprocal of one another. So remembering which one to use, well, think through what you want. If you want radians and you have degrees, put the radian type measure on top. That'll remind you need the pi on top because you're wanting radians. If you've got radians and you want degrees, put the 180 degrees on top. So let's have a look at a couple of examples. Let's just say I have 36 degrees and I want to write it in radians. Well, if 1 degree is this many radians, then 36 degrees, that will be 36 times the size, won't it? So I need to do 36 times my conversion factor. Now I want radians, so I put the pi on top and I put the degrees on the bottom. Obviously the degrees actually cancel out, which is why my answer won't have any degrees in it. It will be in radians. Now I can simplify this fraction here if I like. I can divide by 6 and divide by 6, and then again I can divide by 6. I can get 1 and 5. So my answer is pi on 5. Now I can put radians there as units if I want to, or I can actually just leave it off. 36 degrees is equal to pi on 5. That is the size of an angle. Going the other way, let's say we're given some radians. Perhaps we have a number like pi on 4. Now you'll notice that angle sizes in radians often have pi in them, and that's because obviously pi is so central to how radians are calculated in the first place. Now if I have pi on 4 and I want it in degrees, then I need to use the conversion factor that has the degrees on the top. So I take whatever I'm given and multiply it by my conversion factor. 180 degrees on pi. Notice I've got the degrees sign in my conversion factor there. So when the pi's cancel out, I get 180 degrees divided by 4, which gives me 45 degrees. And you should be able to use that method for converting any number of degrees or radians, one to the other. Now, interestingly enough, we just defined an angle as being 1 radian in size, and we saw that that was an angle that had a radius, and this arc length was also the radius. And it looks like it's around about 1/6 of the circle. We sort of guessed that. Well, we can now use our conversion factor to say, to put this in degrees, we need to just take the number of radians we have, multiply by 180 over pi, and of course that gives us 180 over pi. Now, if you reach for your calculator, you can see why it's roughly 60 degrees. So we've got 180 divided by around about 3 or so. It's going to be close to 60. And to see what it is exactly, 180 divided by pi is equal to 57 degrees and, well, 18 minutes to the nearest minute. So that's a bit of an awkward sort of looking number as a conversion. But remember, we don't often have angles that we use commonly that are exactly 1 radian or 2 radians. Often our round numbers are things like pi on 2, pi on 4, 2 pi, which have pi in them.